And this one needs an advanced strategy. Because what is our main strategy? Change things to sine and cosine. You look at this question, that's already done. Second main strategy, make both sides a single fraction. That's already done. You're like completely stuck. Our main strategy is already done. Can I use any of the formulas with squared? No. They are not squared. Okay? Sometimes you'll be tempted. Like, if you know that sine squared theta is equal to 1 minus cos squared theta, the question is, can I do this? Some of you will ask this, and the answer is a big no with capital letters. Absolutely not. If you want to know why, take something that you know that 3 squared plus 4 squared equals 5 squared, right? So in other words, 3 squared is equal to 5 squared, 25 minus 16, right? So is it true that 3 then is equal to 5 minus 4? No. But you're going to be, as soon as you change it to algebra, you're tempted, right? And you can be like, I want to change 1 minus cos to sine because 1 minus cos squared is sine squared. No. Okay. Best way to lose marks in this unit is make up math that's not true. As soon as we start making up math that's not true, things go bad. Okay? And with numbers, it's like, oh, it's obvious that it's not true. 3 squared is equal to 5 squared minus 4 squared. But 3 is not equal to 5 minus 4. I can't just get rid of the square. So this is also bad. So there looks like there is nothing we can do. Okay. And people want to jump over the line. Okay? Look at this. If I jump over the line and I move this to this side and I move this to this side, it looks like it works. And then you lose all marks because once we jump over that line, the marking stops. You're not allowed on a proof to jump over the line. So I'm going to introduce you to a strategy for this. And there's 2 different names for this strategy. One, which you won't remember very easily.
Sorry for the interruption. Ms. Nowakowski to the office, please. Ms. Nowakowski to the office.
Here's the one you won't remember, I think. So I renamed it Build the Other Side. Mathematically, what we're going to do is multiply by the conjugate. Does everybody remember what a conjugate is in mathematics? Right? Anybody want to really put their hand up and take a stab at that? Should I put somebody on the spot? Or do you think everybody, I'm going to guess almost everybody has no idea and does not remember what a conjugate in math is? Okay? You remember?
No.
No. Okay. So, because you don't remember a word, it makes a strategy hard to remember. Because you're like, what's that again? I'll retell you what the word means in a second, but I'll introduce you to build the other side. If you want 2 things to be equal, why don't we make them equal? And you can choose denominators or numerators. Like, are my denominators the same right now? No. Could I make them the same? Well, if I wanted to make them the same, this one is missing the 1 plus cos theta. And if I multiply the bottom by 1 plus cos theta, I have to multiply the top by 1 plus cos theta. And this one's missing a sine theta, so I'd have to multiply the bottom by sine theta, but if I multiply the bottom by sine theta, I have to multiply the top by sine theta. And I'm just multiplying by 1, so I'm not changing the sides, but I'm building at least something to be the same. This is why I call it build the other side. Let's make something the same. I chose the denominators. You could choose the numerators. But now, on this side, And I'm not even gonna multiply it out. I'm just gonna leave it factored. On this side, that's my denominator. On this side, my denominators are the same. Yay. What do I get in my numerators? Well, on the right side, sine times sine, that will be sine squared. On the left hand side, I'm gonna have to FOIL 1 plus cos theta times 1 minus cos theta. I have to multiply that all out. Do you recognize it as a difference of squares? 1 plus something, 1 minus something. So if I multiply this out, I'm going to get a difference of squares, which is going to be 1 minus cos squared theta. How does this help us? Well, we still have a single fraction. We still already have things in sine and cos. But now we have our denominators the same. And if I look in my numerators, do you see you have a squared now? Big idea. You have this on your formula sheet. Sine squared theta plus cos squared theta equals 1. You would not have to write that down. I don't know why. There we go. It's weird that it erases some of the ink while I type, and if I add extra dots, it puts it back. But you don't have to write that down. Can you see with one mental math manipulation, you can move the cos squared over and get 1 minus cos squared. So you are able to, at this moment, just change this to sine squared without having to show any more work. Are the two sides identical? Yes. So we can go left side equals right side. We are done. This is building the other side. You've done all your other strategies and you're stuck. And we're going to find out if you've done all your other strategies and you're stuck, you probably either have to factor, which we saw just before, or build the other side. Technically, when you have a difference of squares, if you have the same binomial with a different sign in between, mathematically, those are called conjugates. So we multiplied the left side by the conjugate. And some people will just work on this and then actually say here, do you see that these signs, one of them would cancel out on top and bottom? And if they cancel out, you would get sine over 1 plus cos, and you would get the same as the right-hand side originally. But the word conjugate isn't in your head it's not very often. You're like, what'd you do in math today? Oh, this we add, subtracted, a little bit of conjugate work, blah, blah. No, it doesn't very often come up in conversations. You don't remember it very well. But the build the other side strategy is very visual. You make something the same. Made my denominators the same. Therefore, after I did that, now is there something I could do in my numerators to help me? What, part B? Draw the line. So first, in a proof, you're going to look at it and do a little bit of analysis. What do I have? Okay, on the left-hand side, I have some fractions. On the right-hand side, I have a cosecant squared. So I look at my formula, and I see I have a cosecant squared formula is cotangent squared plus 1. But I look at this and say, if I change this to cotangent, is this other side cotangent? No. So it actually probably doesn't help me here. Here, it'd be like, maybe I go with my main strategy. What's my main strategy? Change things to sine and cosine. What can you change cosecant to? 1 over sine. So cosecant squared would be 1 over sine squared. Okay? You're able to do this in one step. I'm going to write down two possibilities and erase the wrong one. Two fractions, both have a sign squared on the bottom. One has the 2 on the top, the other has the 2 on the bottom. Which one is right? What would you do? Don't say it out loud. First of all, you have to decide what you would do. Okay? Because we learn the most when we make mistakes or when we find out we're doing the right thing. Okay? Got your decision of what you would do? Okay. The right answer is the first one. So if you did the second one, you're like, what did I do wrong? Well, if I showed a little bit more work, that 2 would have brackets before I change this to 1 over sine squared. And 2 is 2 over 1. When you multiply your fractions, the tops, multiply the bottoms, the 2 doesn't get dragged down to the bottom. But when you're moving things, sometimes your brain will be like, oh, this moves the 2 down to the bottom too. Could cause some problems. Okay, so this side is a single fraction. This side is not a single fraction. How do I get a single fraction? I need a common denominator. This is grouped, adding and subtracting groups things together as single factors. So it looks messy, but we're going to have to multiply this first one by 1 plus cos theta and the top by 1 plus cos theta. And the second one, we have to multiply by 1 minus cos theta and the top by 1 minus cos theta. And then we notice the bottom are conjugates. It makes a difference of squares. In fact, our common denominator is going to be 1 minus cos squared theta. What do we have on the top? We would have 1 plus cos theta plus a 1 minus cos theta. Can we simplify the top? Sure enough. 1 plus 1 will be 2. Cos and a minus cos cancels out. We just get 2. Can we simplify the bottom? Yes, that's our big idea. So no work needs to be shown. You can just immediately change that to sine squared. And now our left side is equal to our right side. QED, we are done. So with this, I'll write down numbers. Not a lot here. Actually, I'm just going to get you to circle 12A. But I'm going to get you to turn to page 620 is a blank page. And I made a list of strategies. I probably should have ordered them differently. I'm going to put numbers as of, like, I'm going to put a 1 beside both of these ones because that was our first main strategy. So those ones are connected. Then the second thing we learned today was the Pythagorean identities. Sine squared theta plus cos squared theta is 1. Tan squared theta plus 1 is secant squared theta. Okay. And that's also connected to this one, number 2. And then number 3, these are our advanced strategies. Build the other side and multiply by the conjugate or factoring. You are going to use those ones when other strategies don't seem to work. And I'm just going to put, let's go. Just going to put an orange star beside this one. This is sort of a preliminary thing. You're always looking at the left side and the right side because they kind of give hints to each other of what you should do. You see your right side has a common denominator of cos theta, and your left side has a cos theta and a sine theta. You might need to either build the other side or factor something out. They kind of give you a hint. So always be aware of what the other side is, because it can give you hints of what you should do.